Hello everyone, welcome to our channel. Please subscribe, share and like this video. In this video I would like to explain about multiple regression analysis. We are going to do how to analyze multiple regression in SPSS, but before it I would like to explain first what is multiple regressions. Multiple regressions is an extension of simple linear regressions. It is used when we want to predict the value of variable based on the value of two or more other variables. The variable we want to predict is called the dependent variable, or sometimes we call it as an outcome, target or criterion variable. The variable the variables we are using to predict the value of the dependent variable are called the independent variables, or sometimes it calls the predictor, explanatory or regressor variables. For example, you could use multiple regression to understand whether exam performance can be predicted based on revision time, test and anxiety, lecturer attendance, or gender. Or the other example is you could use multiple regression to understand whether daily cigarette consumption can be predicted based on smoking duration, age when start smoking, smoker type, income, or gender. That's the examples. Multiple regression also allows you to determine the overall fit of the model and the relative contribution of each of the predictors to the total variance explained. For example, you might want to know how much of the variation in exam performance can be explained by revision time, test anxiety, lecture attendance, and gender as a whole, but also the relative contribution of each independent variable in explaining the variance. So when you choose to analyze your data using multiple regression, part of a process involves checking to make sure that the data you want to analyze can actually be analyzed using multiple regression. You need to do this because it is only appropriate to use multiple regressions if your data bases the assumptions that are required for multiple regression to give you a valid result. So before we do the multiple regression, you have to base the assumptions, and I will show you how to analyze the assumption before do the linear regressions in the next video. SPSS statistic will generate quite a few table output multiple regression analysis. In this section, I show you only the three main tables required to understand your result from the multiple regression procedure, assuming that no assumption have been violated. We focus on the three main tables you need to understand. So I have data like this. There are independent variables, three independent variables and one dependent variables. First, you have to create the variables in variable view. The name variable is x, first x, second x, and the third x and y. As usual, you have to make sure that measure is scale. After you make variables in this variable view, go to the data view and you have to move or copy this data on your Excel to your SPSS like this. I'm sorry. And then the Y variable, move to this. After you move the data from your Excel to your SPSS, now we are going to show you this type of how to do the multiple regression analysis. First, you have to go to the analyze and then go to regressions, choose linear. When the dialog is open like this, you have to move variable dependent or Y variable to dependence box by click this button, and then you have to move all the independent variables to independence box by click this button. Make sure the method is entered. When you want to analyze the assumption, you have to go to statistics, like collinearity diagnostic or Darwin-Watson. You have to check this and continue, and then plot, normality, probability plot, and histograms. After this, you have to enter the OK button, and then the output is shown in this. As I said that we focus only to the three main tables. You need to understand is the first is model summary, ANOVA, and coefficient. The first table of interest is model summary. This table provides the R and R square and adjusted R square, which can be used to determine how well a regression model fit the data. The R columns represent the value of R, the multiple correlation coefficient. R can be considered to be one measure of the quality of the prediction of the dependent variables. In this case, it has a value of 0.793. In this example, indicates a good level of predictions. The R square represent the R square value, also called the coefficient of determinations, which is the proportion of variance in the dependent variables that can be explained by the independent variables. In this case is x, 1, 2, and 3. You can see from this column, it's about 0.6 to 9. It's mean that the independent variables explain 62.9% of the variability of our dependent variables. It's called Y. However, you also need to be able to interpret just the R square to accurately report your data. This is the first table, and the second table you have to know is ANOVA. It's called the F ratio in the ANOVA. The ANOVA test whether to overall regression model is a good fit for the data. The table shows that the independence variable statistically significantly predict the dependent variables because the value of significant is less than 0.005, and also you can see this value, the F value, and you have to compare with the F table. For estimate model coefficient, you have to take a look in this table. You can test for the statistical significance of each of the independent variables. This tests whether the unstandardized or standardized coefficient are equal to 0 in the populations. If the significance less than 0.05, you can conclude that the coefficient are statistically significantly different to 0, and you can also see the t value, and corresponding v value are located in the t and c columns respectively. In this case, the first independent variable is significance. The second variable is not significant, and the third variable is not significant. I hope this explanation is useful for you. Thanks for watching. See you next video.